auditorium and everyone watching us live online. So welcome to the International Space University Space Studies Program Distinguished Lectures number 9. So yeah, it's been a while. We had pretty awesome lectures and panels and debates, and this one is no exception. The only exception is, unfortunately, this is our last event with our Jim Green. That is sad. That is sad. So for the ones who are watching us for the first time, Jim Green is one of our core chairs in the program here in Portugal, or Portugal this year, and he is the former NASA chief scientist and currently serving as the senior advisor to the Office of the Chief Scientist at NASA headquarters. So today we will be talking about where the science fiction meets science, the facts, and the best way to do it, you know, to look at movies. And The Martian, which I'm sure everybody knows, Jim was a consultant as they were actually making the film, so he knows what it takes. And actually now today he will be talking about not only the movie, but actually, what is next in terms of NASA's plans on Mars? With that, Jim, once again, thank you so much for joining, and the stage is yours.
Thank you so very much. Right. So it's really a pleasure to be here talking about science and science fiction, because there's quite a dance that goes on over time, and this is something Carl Sagan said. If you look back at the history of Mars in particular, the things that were discovered on Mars by Percival Lowell and others with canals and canale, H.G. Wells wrote War of the Worlds 2 years later, and so these kind of things go back and forth, and this is another really tremendous example. Now, what I like about this movie in particular is what I would call hard science fiction, which means it tries to take what we know about Mars and or know about a particular part of science fiction, and then project into the future what will happen. How I got involved in this is Ridley Scott, who actually directed the movie, had an opportunity to talked to NASA because he wanted as realistic a setting as he possibly could get. So he called NASA headquarters, and at the time I was head of planetary science, and my Mars czar, which is what we called him, the Mars czar, which is the head of the Mars branch at NASA headquarters, had just retired. And so I was acting Mars czar. And in the movie, Chiwetel Ejiofor plays the Mars czar. Okay, that's pretty close to a role that we actually have in NASA. So I had an opportunity to talk to Ridley and his team for about 45 minutes or so, maybe an hour. I answered as many questions as I could. He asked me if I had read the book. I hadn't read the book, and so before I got off the telephone call with him, he'd already sent me the script. Okay, and I said, well, what we need to do is take a tour. You need to see some of the facilities and things that NASA's thinking about in terms of habitats, control centers, and then it's from that framework that you're going to develop your sets and everything else. And he said, great, how soon can we do it? And I said, well, we can probably start next week. So this was like on a Wednesday or Thursday, and so I got the ebook, The Martian, because I hadn't read it, and that weekend I read the book, read the script, and then came into NASA headquarters to the Office of Communication where we had a meeting, and at the meeting is where they decide, okay, how much resources we're going to put together, what are we really going to do, what NASA's role is as requested by Fox Studio and Ridley Scott to participate in this. And so they turned to me and they said, Jim, what do you think we ought to do? And I said, we need to be all in. Whatever Ridley wants, we need to do it. All right? Because this is as close to what it's going to look like and feel like when humans actually walk on the surface of Mars. All right? And they said, okay, great. Jim, you're going to lead the effort. So no good deed goes unpunished, right? So that started a wonderful relationship that we're going to talk about, and I'll show you the results of that. But let me segue over to Andy Weir in the book. So Andy Weir, who's now a good friend of mine, really enjoy talking to him. He's got a wonderful sense of humor, and you can see it all through the book. I mean, he's really, the smart-ass Mark Watney in the book. That's Andy Weir. But he wanted to be a writer. Didn't really work out for him right away, so he had a job as a software engineer at one of the laboratories in California. And so he started, since he just had this itch to write, he started writing The Martian chapter at a time and then posting it on his website. Okay? So this, what he calls a clunky website. And it began taking off. People liked it. People read it, would give him comments, and he would take that in. And so he kept doing the next chapter and the next chapter and the next chapter. And Andy told me at one time that he would, get Mark Watney in a situation and then spend like 3 weeks trying to figure out how to get him out of it. All right. And of course, what he wanted to do is he wanted to do it as a fact-based challenge. What would Mark Watney really do? How would we accomplish these things? And so at the end of the, 32 or 36 chapters in the book, they were all out there. He was done. He thought that's it. Anybody can read it. It's all in PDF, a chapter at a time. He had a bunch of emails from people he knew that said, can't you just put it into an ebook? All right? Just pull it together and make an ebook out of it. He said, all right, he'll do that. So he logs on Amazon and then follows the instructions and creates the Martian ebook. Now, Amazon requires you to sell it. And so I think this is how it goes. Andy, forgive me if I get this not quite right. But Amazon says the minimum sale for an ebook is 99 cents, and Amazon gets like 79 cents of it, or 70 cents or something like that. And Andy gets 29 cents. So that's what he did. He made it as cheap as possible. He then told everybody, there it is. You just download it off Amazon, to your heart's content. And that just took off by word of mouth. Became incredibly popular, and in no time, it was in the top 5 science fiction novels that Amazon sells. Pardon me. So you can get that listing and see what it is. So what happens next is all of a sudden an agent calls him and says, we think you've got a really hot product here. We would like to make a hardback book out of it. I mean, when you think about it, that's pretty crazy. Doesn't it go the other way? Doesn't the hardback come out first and then the ebook? But they were also thinking, Crown Publishing was also thinking about putting it in a number of languages and distributing it, and a book publishing company really has the ability to do that. And he said, okay, you're hired as my agent, go work it. 1 week later, he tells me, Fox Studio calls, and they say, we would like to make a movie. We'd like to option to make the movie, The Martian. And Andy said, go talk to my agent. And so they cut a deal. And when you do that, you may or may not really end up with a movie. All right? That's part of the problem. If a studio buys a product, they're buying it perhaps because they want to make the movie, or perhaps they don't want anybody else making the movie. All right, there's a strategy there. Who knows what that strategy is sometimes? But he then did have Fox have the right to make the movie, and a really talented writer, screenwriter, Drew Goddard. Drew Goddard wrote the first script, and he was gonna direct the movie, but Drew got lured away on a big Marvel movie. And so Ridley Scott came in and took over. Now, by that time, Drew had already asked Matt Damon to be Mark Watney. And so, as I understand it, Ridley interviewed Matt and then decided, okay, that's all right. We'll have Matt. Now, once everyone knew that Matt Damon and Ridley Scott were doing The Martian, they just came out of the woodwork, right? So that now is the kind of background that sets the stage for what I think really a wonderful collaboration that we did for many months as Ridley Scott and his team really produced a fabulous movie. So let's talk about an overview of the movie. And the best way to give you an overview of the movie is to show the official trailer, the publicly available official trailer, okay? That should not be blocked as we stream this, all right? Okay. So if we could have the lights down a little bit, let's hear the trailer. Can we turn the lights down? Is that possible? Oh, of course, they all left. Okay. They'd seen the movie, so they didn't want to hear about this. Ah, super. Let's do it. This is approved for appropriate audience, by the way.
Every human being has a basic instinct to help each other out. If a hiker gets lost in the mountains, people coordinate a search. If an earthquake levels the city, people all over the world send emergency supplies. This instinct is found in every culture, without exception.
At around 4:30 a.m., our satellites detected a storm approaching the Ares 3 mission site on Mars. The storm had escalated to severe, and we had no choice but to abort the mission. But during the evacuation, astronaut Mark Watney was killed.
I'm entering this log for the record. This is Mark Watney, and I'm still alive. Obviously. I have no way to contact NASA or my crewmates, but even if I could, it would take 4 years for another manned mission to reach me, and I'm in a hab designed to last 31 days. So, in the face of overwhelming odds, I'm left with only one option. I'm gonna have to science the shit out of this. Okay, let's do the math. I gotta figure out how to grow 4 years worth of food here, on a planet where nothing grows. But if I can't figure out a way to make contact with NASA, none of this matters anyway.
Houston, be advised.
We've got a video message. It's directed to the whole crew. Play it.
Mein Gott. Mark Watney's still alive.
In your face, Neil Armstrong.
We left him behind. Let's go get our boy. This is something NASA rejected, so we're talking mutiny. And if we mess up the supply rendezvous, we die. If we mess up the Earth gravity assist, we die.
It's space. It doesn't cooperate. I guarantee you that at some point, everything's gonna go south on you. And you're gonna say, this is it. This is how I end.
Is it possible that he's still alive?
Okay, that sounds pretty good, right? That's a movie we ought to go see. But indeed, what we then did was start a series of tours to, first place we went was Johnson Space Center. And the key person that was there was the set designer, Art Max. And Art did Gladiator and just all the others that since then that really created beautiful sets. And so I would take Art. Oh, actually, there's Art right there. And we went through the activity at JSC. We showed him control centers. We showed him the vehicles. We showed him some of the mock-ups, the modules. And he would walk in and he'd walk around and he'd be opening drawers and doing all kinds of stuff. And he said, well, what are you doing? How are you doing this? And how are you doing that? And I said, Art, we haven't figured it out. But if you come up with something really good and put it in the movie, we might use that, okay? There's nothing wrong with that, okay? And in fact, I said, I watched the original Star Trek, okay, when that came out. And Captain Kirk is up there on the surface, and he dials his little communicator, flips up the phone, and calls Scotty, orbiting on the Enterprise, and talks to him. And I said, from this iPhone, I can call an astronaut on space station. It's no longer science fiction. Okay, and so you should have the liberty to use your artistic ability to create, the look and feel, taking whatever we have done here at NASA as a starting point. And I think he did that. He did that really well. I got many of examples where he did that. So another one is the habitat. So here is a basic Mars habitat. Here's what the inside of it looked like. And of course, in the movie, you saw several scenes of the habitat that they created. And in fact, the look and feel is indeed pretty similar. Now, in addition to that, here is the rover. This is the NASA's multi-mission space exploration vehicle, MSIV. Here is the inside of it, GoPros, little screens with all kinds of stuff, information. And in fact, here is what is the Martian vehicle, which I think looks neater, actually. But, same basic look and feel about it with the screens. All right, really nice. We went into the JSC suit room, okay? And in the suit room, let me go to that. So in the suit room, we had what was available to see were the EVA suits, the extravehicular activity suits. So these right here, and Art is playing around with them, looking at their consistency. And he had a camera with him, and he must have taken, 2,000 pictures. It was constantly clicking, click, 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 click. And he was talking to the suit people, and he said, let's see the gloves and all this. And he said, how hard is it to take a knife and poke a hole in these things? And I could see the horror on their faces. And they said, very sternly, very seriously, we do not let the astronauts around sharp objects. Okay? So, that conversation went on, and we were walking out from the suit room, and I said, Art, look, don't use, and I used this term, and I may have regretted it, the Pillsbury Doughboy suits on the surface of Mars. Okay, there's a new type of suits that NASA's investing in and checking out, and they are surface suits. And in fact, Dava Newman, who ended up being the deputy administrator at NASA before she came, was working on a suit design. And so I gave him the website, and we talked about it. And of course, what Art did was blend these two concepts. You can see the helmet, see what's, the functions there. You can see what it ended up on the surface suit for Mark Watney. All right? So I think he did a fabulous job taking in this kind of information and then creating a beautiful look and feel in the movie. And that's what a great set designer does. We also went into mission control. We went into not only the Apollo one, but also the International Space Station, and he took pictures, etc. We also went to JPL after this, And at JPL, he got to see how we manage the robotic missions. Okay, so we manage the robotic missions separately at Jet Propulsion Laboratory in Pasadena versus the human exploration activities at Johnson Space Center. Okay, and so he saw both those control centers and merged them, okay, into the beautiful control center that they used. Now, another neat thing about it is he said, well, what's on the screens? You know, what are we going to put on all these screens? And I said, I'll just give you a bunch of screen captures of real data. Okay? And so we just took screen captures of real data from our robotic systems at JPL, sent them the JPEGs, okay? And then, of course, they did their own top screen like this, but they're actually looking at, on the screens, real data, all right? So, in the movie, the initial problem, of course, is the impending dust storm that comes. And you see everybody in one of the HABs, and you see Beth Johansson, dialing up. Here is the storm. We can see it coming. So how realistic is that? It turns out it's really pretty realistic in terms of looking at the climate on Mars. We have three-dimensional MHD models of the Mars climate. We can get the temperature, pressure, and wind velocity anywhere on the surface. And we do that by not only physics-based models, but we bring in the data from the rovers and bring in the data from the orbiters, and it's assimilated just like we do Earth science satellites to get the weather, okay? And then we let it evolve. We even, since then, have actually modeled complete dust storms. We now can do that. And all that's done out of supercomputers at Ames Research Center. And when I was head of planetary, I recognized the huge step that this group at Ames was doing in the modeling area, and I wanted to make sure we supported that, because not only do we need it for our own robotic missions, but knowing that in the future, human exploration, not knowing where they're going to land or what they're going to do, are going to need to know the weather. And indeed, that concept works really well. Now, here's actually one of the screens out of a full three-dimensional MHD run of the global circulation model showing winds. Okay, and right here at where that arrow is where the Ares 3 station is. So this is, of course, the third station that from the movie you land at a different location somewhere on Mars, and perform experiments and do a variety of things, and so they call that the Ares landing sites, and this is the third one. So this concept we can pretty well do now. This is not science fiction. Now, what is science fiction is the storm. All right, is the dust storm. And the reason, and I asked Andy Weir this, I said, well, you knew better. The dust storms on Mars aren't anything like this, okay? The winds on Mars can be as high as 120 miles per hour, okay? But if you stuck a flag, it would not straighten it because the pressure is so low, okay? All right, and so you're not going to have this massive dust storm like you see in the movie. And Andy said, well, it's very simple. I wanted to make this man versus nature, and I was going to let nature, give them the first punch. Okay, so I really wanted a dramatic input here. And I said, okay, well, the dust storm is very unrealistic. So what do dust storms really look like on Mars? Well, there are a couple areas like these where there are valleys that can kick up dust that look from space pretty gnarly, okay? But these are very local, and they don't go very far, and they die pretty quick, okay? But here's what a real dust storm looks like, okay? This is a dust storm as seen by opportunity, and you can see the day number. SOL, S-O-L, is what we use to say that's a Martian day. Now, Mars day is 24 hours and something like 40 or so minutes. Okay, so it's not like our day, which is 24 hours. It's a little longer. But you can see, here's 5, 20, 25, 33, 35. So 30 days it's taken this dust storm then to build up and block out the light from the sun. Okay? Now, this is what we worried about a lot with our rovers because they were all solar powered until Curiosity showed up, and then now Percy's got also the nuclear power. But you can even see it coming in some of the images, but it just changes the opacity, so it doesn't give the punch as was necessary for Mark Watney to be stranded. Now, another thing, though. So when Art Max came, after I'd read the book and I'd read the script, which was fabulous. The script was great. I gave him 28 suggestions, maybe 26, how to change the movie. Okay, just tweak it a little bit here and there. They only took 3, okay? And one of them is some of these storms, these dust storms, actually generate a little lightning, a little discharge, okay? And so in the movie, you see as the dust storm comes over the mountain, you see the lightning, and it makes it even more foreboding. But we see it from space. So here's from Mars Global Surveyor is seeing, flashes of light that go by. And then this is, of course, an artist's conception. It's not meant to be a real dust storm. But after the dust storm goes, you can actually see where there's actually been strikes on the ground. And that's because the dust can get charged. It can get lofted 10 kilometers or more, okay? And then potential difference causes a discharge, okay? So it's not like lightning we have today. It's kind of a okay, no big deal, but it's kind of neat. You get a little flash, and so indeed they added that in the movie. Now dust, like Mark Watney is laying in this pile of dust, does accumulate over time, all right? So no one dust storm takes huge amounts of dust and then creates piles, but it will pile up over time. And so here's Curiosity making its way through this dust field after it landed in Gale Crater and then is starting to go up Mount Sharp. And so it's running around these big dust dunes, okay? And so these are real images of those dust dunes. And of course, then in the movie, Mark Watney is laying in there half buried, okay? As the rest of the crew takes off and goes home. Now, one of the most fantastic things about Mars that we didn't know about was local turbulence in the atmosphere, creating these little swirly winds that then indeed pick up dust and move it, and you can see them. And so we call them dust devils. Now, the wonderful thing about the dust devils is when we landed Spirit and Opportunity in early 2000, we didn't think they'd last very long, okay, because we knew there was a lot of dust in the atmosphere, and the dust settles out over time, and it would accumulate on the solar panels. And so we figured, the objectives of those missions were going to be done in 90 days. So we wrote down what they could do, what we thought they could do as requirements in a 90-day period. Okay? Well, these dust devils would come along and sweep the dust right off the panels. Really wonderfully. You could watch the power. You had power over time. You watch the power degrade, and then all of a sudden you just shoot up to 100%. It was unbelievable. And it really breathed new life into these rovers for years. Okay? Spirit lasts 6 years. Opportunity lasts 14 years. Okay? Really phenomenal. And so here you can see what it does. When the mast camera looks down and looks at the solar panels on Spirit, here's where a dust devil has come along and cleaned them off. Now, these dust devils actually have some neat height to them, okay? And so, showing the images that they wanted and talking about the climate and everything else, then they reflected that in some of these beautiful scenes where Mark Watney is traipsing around Mars and seeing these beautiful vistas and these very tall dust devils. Now, we've also recently found that a lot of the wind in Jezero crater, where Perseverance is at, blows out from the middle of the crater and on up the crater wall. Really neat. And we hadn't really looked at that or studied that much, but several scientists have written a number of really good papers in that particular area. Now, here's our assets today at Mars. Other than Earth, Mars has more active robotic missions, orbiting, roving, and landers than any other body in the solar system, okay, that are active, all right? The Moon has far more that are not active, okay? The Moon has about 100 objects that are laying on the surface that are derelict on the Moon, because the Moon's gravity is so lumpy that anything in orbit doesn't stay in orbit very long, and if you lose your attitude control because you've lost all your propellant, the Moon will bring you down, okay? Everything that's been orbiting the Moon is down on the Moon right now, other than the couple things that are there now, but there's Chinese mission orbiting, and I think there might be an Indian mission orbiting. I don't know if that's active still or not. At Mars, it's very different. So we have Mars Odyssey that's been there now more than 20 years. Okay, this is a NASA mission, and it's really a fabulous mission, making all sorts of mineralogy measurements, looking at the infrared and making temperature measurements and doing a number of things. We worked with ESA on Mars Express, NASA and ESA mission, and then there's a Mars Reconnaissance Orbiter, and MAVEN, and then India has put in orbit the Mars Orbiting Mission, or MOM, okay? And then ESA and the Russian Space Agency put in orbit the Trace Gas Orbiter. And then in this last opportunity, since the window to go to Mars is every 23 months, the last one, the UAE put HOPE in orbit, and China put their Tian-1 in orbit. And then also the landed assets are quite a few landed assets. We have Curiosity, we have InSight as a platform, making seismic measurements, made well over 800 seismic measurements already on Mars. And a couple really nice Marsquakes, really nice, okay? And Perseverance with Ingenuity, and then of course Zhurong, the rover and the platform from China. Okay, so those are the assets. In the book, Andy was projecting ahead, knowing how we use these spacecraft as relays, all right? Landed assets, gather data, move the data up to an orbiter. As the orbiter flies over, it stores it, and then the orbiter will send it back to Earth. If we didn't do that, then we'd be pulling a trailer with a big dish behind these rovers, okay? So this is already an element of an internet where we're routing through these orbiters, okay? And right now we're discussing how to create a solar system routing internet, okay? Where international participation can occur, many nations can get involved, and we'll be able to communicate when humans are actually on Mars. You can send them emails even when Mars can't be seen directly and may be behind the sun for several weeks, okay? Because you use an internet, a solar system internet. Now we're working on that. Some really neat ideas. Andy felt that there were going to be, okay, there we go. Still a bunch of orbiters, 12 for NASA and 2 for ESA, but there's so many other countries now that have joined, which is to me a far more appealing aspect of the world exploring our solar system. Now, the Martian, the heart of the Martian, is that it's a science mission. Okay, and so. These are human-enabled activities. There's intelligent sample return. He's out in the field. If you watch them carefully, what they're doing, they're collecting samples. You know, they're deploying instruments. They're doing a number of things. And so it's intelligent sample return, it's instrument placement, it's potentially drilling, it's rapid access to diverse geological regions, and Mark Watney certainly does that. We'll talk more about where he ranges and how he goes and what he does. Rapid response to changing conditions. Well, they got the heck out of there as fast as they could. And of course, we want them to look for signs of potential life that's there now, or even past life. Now, we are not using humans to do a lot of those tasks, but some of those tasks are actually being done now with the Perseverance rover. And it is designed to core rock, okay? So it has a cylinder that spins. And the rover is a 1-ton rover. Actually, it's more than that. It's heavier than that. And it can put some oomph behind that, and you can literally drill a core in granite, okay? And so this drill spins. You then have a core. The core is like a piece of chalkboard chalk. Now, you probably don't know what that is, right? You've never been on a blackboard, right? So it's like a large Crayola crayon, okay? It's a large Crayola crayon. Just think of that, all right? So we've got some wonderful guests here today. So here it is. Here's what the core looks like, and it's put in a metal sleeve. And then the concept is we're going to take a bunch of these, hang on to them for a while, and then lay down a whole pile, okay? Now, currently, we've got 8 or 9 samples, one an atmospheric one, and the rest are rock samples that we have already created, and they're already in these sleeves. And we will soon be finding a place. In fact, there's a target place where a bunch of these are going to be dropped, and then they're going to be moved on. The idea of creating samples and then dropping them is really quite ingenious, because we want those samples back in the lab. Rock samples are the history of Mars. Mars was a blue planet early on. It looked like the Earth 4 billion years ago. 2/3 of the northern hemisphere was underwater, and in some places more than 1.5 kilometers. But it went rapidly through climate change. Now, we don't know what that climate change is exactly. We don't know how rapidly it went through it, whether it was 10 million years or 100 million years or 200 million years. But indeed, it's in the rock record. And by bringing this rock record back, that is a wonderful opportunity for us to really interrogate and understand what Mars is doing. That's what the Ares 3 crew was doing, studying Mars. They talk about what they're doing as they're out in the field, and you can hear the kind of banter going back and forth as you would expect astronauts to do, as part of life and human interaction. What's really great about the rock samples is this: when we look at the mineralogy of rocks here on Earth, there's about 5,700 unique minerals, okay? But about 340 of them can only be made from dead life, okay? So rock samples are critical for us also to look back in time and perhaps see an era when Mars was not red, but green. And we don't know if that happened. We don't know if that existed. We don't know that that's there, but hopefully it's in the rock record. Okay? So rock samples are really important. Now, we also had a couple experiments that are what we call feed forward, sort of like the next generation things that we want to do. This is one of them. This is my favorite picture of Moxie, okay, which Jeff talked about. And he didn't show this picture, but I like it because it shows you how big it is. It's not very big at all. There's a coffee cup, and it looks pretty simple. They struggled to put this together. They were having all kinds of trouble, but they got it all worked out. Part of this is that, and Jeff talked about it, is when they open the port, the gas, the atmosphere of Mars comes in, 95% of it is CO2, carbon and oxygen, two oxygens connected to carbon. And you zap it, you just give it a little spark. If you do that just right, you pop an oxygen off. So then you have CO and O. And as you do more of that, the O doesn't like to stay single. It just goes to O2. So you end up quite quickly with CO and O2. Okay? Now, if you gave it too much of a zap, you pop the carbon off, and then the carbon lays at the bottom of the instrument and gungs it all up. Okay? So they really had to work this. So they have to be able to monitor how much they make. They've got to keep it working. It's different atmosphere in the morning than it is in the afternoon, than it is in the evening, than it is in the summer, the winter, the spring, and the fall. Okay? And so by running this instrument over seasons and through different times of the day, you can get a baseline for how well it works. Well, it works great, as you found out. In fact, it works just like it did in the laboratory, which was phenomenal, all right? And from that, they actually can scale it, and they can create a full-size Moxie, put down on the surface, have it work, and in 12 months, generate enough oxygen to bring the crew home, okay? So some really exciting things can happen. Now, you don't know how the astronauts in the Martian landed, okay, which is really tough. It's really tough to get not only the bases there, but the humans there. But, Andy started out right away, well, they're there, and we'll deal with it. But getting off the planet is also difficult, and you need the rocket fuel. And so even though he doesn't talk about it, it's systems like this that are really going to enable it. And by feed forward of doing Perseverance, we know how this can go. Okay? Now, another really great thing about the movie is Andy timed this to coincide with Thanksgiving. Okay? So Ares 3 crew was to stay on the surface 30 days and come home. It is, in NASA's parlance, a short stay. There's two types of stays. One's a short stay, one's a long stay. 180 days to get there, short stay, you're there 30 days or so, and then you come home at about 220 days. All in that nearly that same window of opportunity. The long stay is you stick out more than a year, okay, before everything lines up again, and Mars and Earth are on the same side of the sun, and then you can, start the process of coming home. And so he picked an opportunity for which the Ares crew perfectly arrives November 7th in this window. This is a real window in 2035 that enabled them to actually have a Thanksgiving dinner, which enabled them to actually have a special gift from NASA, which are real potatoes, not these freeze-dried things you get in, add water, whatever it is, but real potatoes. And as you notice, here's winter, spring, summer, fall. This is what it would shake out on Mars. and Sol, as I mentioned, is the Mars day. And so there's 200 or 687 Earth days for one Mars year. Okay, and so that matches really well. So he did a great job matching that. And then, of course, as Mark Watney, particularly in the book, if you've read the book, you know he runs into all kinds of trouble, one of which is a dust storm, which he goes around. He goes around a dust storm. And that's because there's a dust storm season. Here is the exact dust storm season that he would run into. And these seasons occur when the southern hemisphere of Mars is in summer. Okay? Mars is an elliptical orbit. And its closest approach, called perihelion to the sun, is when it's southern hemisphere summer. That's the time you can catch this dust, and it can really take off. And so we're going to change my mind. I'll speak louder. So while we're scrambling, maybe I can take your questions. Testing. Yeah, just a sec. Okay, now it's up. Yeah, they are done really well. So the scenery that you see, and we're going to talk a little bit more about that too. They filmed it in Jordan. And so they picked scenery that was most like what we sent them. And we sent them high-resolution images of Mars from the Mars Reconnaissance Orbiter. Okay? So that worked out really well. And then, of course, there's this scene from the movie where Mark Watney says something absolutely apocryphal, which is...
In your face, Neil Armstrong.
Yeah, so I didn't like that. I love the movie, but I didn't like that because in reality, in your face, Mark Watney, because Opportunity was able to stay on the surface for more than 5,000 days. Okay, he just was there, a tenth of that. All right, so our imaging that we sent them, you can go right in the book. You get the longitude and latitude of the Ares 3 station. And we did high-resolution imaging. We tasked the Mars Reconnaissance Orbiter to then, when it flew over this area, image it. Okay? And here's what the images look like. So you see, here's an entire strip of the Mars Reconnaissance Orbiter as it flies over this particular area. And this is the exact location of the Ares 3 base camp. And it's in Acidia, Planitia. And here is the set, so to speak, the where the scenery is part of the character of the movie. You see, this is where they picked, and it had a great look and feel about it. So they were filming this in Jordan. So let me mention, the Mars Reconnaissance Orbiter has been in orbit since 2006. Okay, it's in 2006. You see this table over here? That little table? If that table sat on the surface of Mars, the Mars Reconnaissance Orbiter could see it, and it's up at 400 kilometers. All right? It's a high-resolution imaging system. All right? Okay, so it has been operating since 2006, and it has imaged Mars at that resolution only about 4 to 4.5%. Okay? Yeah. So how could that be, right? Because Mars is a big place. Okay? We have to recognize this is really a huge planet. The surface area of Mars is the same surface area of Earth without the water. If you just put all the plates back together, That's the surface area of Mars. Okay? It's huge. It's really huge, which is great. I love it. Got plenty of places to go around. And here's where they're at. So this is a Mercator projection of Mars that shows in color what the highs and the lows are. The blue is the low areas on Mars, okay? And the reds and the whites are the very tall areas, okay? And it has these fabulous features. You see this huge canyon right below where Viking is. This is Valley of the Mariners. It's what its name is. And if you take that out of Mars and you brought it to Earth and you put it across the United States, it would link the Atlantic and the Pacific. So if you've ever been to places like Grand Canyon and you think it's spectacular, forget it. That's spectacular, okay? And it has these fabulous shield volcanoes, okay? So you see the really big one at the top. This is Mount Olympus, okay? It's a shield volcano. One of the reasons why we don't think of plate tectonics as being anything that's happened much on Mars is because these volcanoes build up. When we have here on Earth, we have magma that pokes through perhaps these plates, or even where the crust is thin and they can poke through. Because the plate is moving, they poke through and create a volcano, and then that moves, and then poke through again and create a volcano. And so you see islands that have been created because our plates are moving and the magma is coming up and creating them, okay? Now that happened over here. So you can see the three tall volcanoes. That's nice. Maybe some sort of plate tectonic action happened there. But by the time you get to Mount Olympus, that's not the case. If you were to carve Mount Olympus out of Mars and brought it to Earth, it would cover easily Portugal. Portugal, okay? So you haven't seen anything like the features on Mars. Why are they so big, or why are they so deep? And that's because the gravity is lower. The features can be accentuated, okay? So think of it that way. So here are the set of things that have been on the surface and operated. There's many other things that been on the surface and didn't operate, so I didn't put those here. But you see, the active ones are Perseverance, Curiosity, Insight, and Zhurong. And then you see the ones that are dead are Viking 1, Pathfinder, Opportunity, and Spirit. And this is really Pathfinder and Sojourner. Pathfinder is the platform, and Sojourner is the little rover. Here, look right above where ExoMars is going. That's where Ares 3 is, okay? So that means, when Mark decides to trek out and go somewhere, and he's going to go to Pathfinder, we can trace his steps. We know how far away that is. We can see what it's going to look like, okay? Now, the other thing that we're finding on Mars, which is pretty spectacular, was found by Curiosity when it landed. Now, it had a percussive drill. So if you can imagine a straight screwdriver, if you take a straight screwdriver and hit the surface, rotate a little bit, hit it again, rotate it, so you go bang, 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 you pulverize whatever's there. And then you scoop that stuff up and you bring it into the rover and you just tease it apart. You look at the mineralogy, you look at the composition, and of course you're looking for organic material. You're looking for potentially signs of life, or whether Mars was habitable in the past. And these are the first two holes it dug. This was a sample hole, the first top one. That's the size of a small coin, okay? About a dime. Okay, it was a real small coin. And the other one goes down a good centimeter or so, maybe a centimeter and a half. But when the scientists saw this, they were shocked. Okay? Because what did we bring up? Was it red Mars? It's not. It's gray Mars. It is Mars of old. It is fabulous sets of soil that just has a red patina of oxidized iron on top of it. And in fact, it's got carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Everything between my two fingers in that soil. All right? So it has what it takes, like Earth, to potentially, in a habitable time in its past, harbor life. So it's a really fabulous set of discoveries. But what's also important is the soils are moist and they have nitrates in them. Okay? And the reason why that's important is because we can grow food. We can grow food on Mars. It's got all the macronutrients and the micronutrients. So the concept of having, vertical farming and doing a number of things there is very viable. Now, Curiosity also saw some toxic material called perchlorates, but it turns out they're not ubiquitous, which means they're not everywhere. It is moved into areas where there's no perchlorates. And perchlorates are actually easy to wash out of the soils. All right? So even though Mark Watney went outside, took this top layer off, brought it in, and began the process cutting up those potatoes and growing food, he could do this. This he could do. This is realistic. All right. Now, where Curiosity is, the soils are alkaline. Okay. So that's good for like beans and asparagus. Okay. Rather than acidic, which is better for potatoes. Okay. But we're going to assume that there's going to be different types of soils. There'll be acidic soils also. We think an aspect of the ancient Mars ocean was also salty and acidic. So there's no reason to think that that's the case. But I have to tell you, if he was growing asparagus, and I had to eat asparagus for 2 years or 3 years, I think I'd just take my helmet off and go on outside. But potatoes I could actually do. All right, and that's what he did. Now, one of the unfortunate things is, pardon me, I didn't recognize at the time the thought of a sunset on Mars. Okay, so there's a great scene where he's sitting there in a sunset and he's thinking deeply. He's worried about his future, and then planning, contingency planning, looking at the options. Here's a real sunset on Mars. It's blue. It's not red. And I really wished I'd have thought about that and given him that hint, because I would have liked to have seen a blue sunset instead of the red one. That would have been really great. Now, Mars's temperature is really cold. This is also quite accurate. Okay, he's in the hab and he's walking around and he gets cold really easily, right? He's always worried about the cold. Well, how cold is it? Okay, in one day, the temperature changes by 170 degrees Fahrenheit. Okay, or about 100 C. Okay, in one day. Okay, that's a lot. So here's temperature measurements. We also can make measurements of the ground temperature, and you can see there's a little lag between by the time you heat up the ground. Okay. So Mark has decided that since he's going to use the mobile vehicle and he's going to drive a significant distance, that he's going to need some heat. So he runs out and he digs up the radioisotope power system. Okay, so this is the real deal. This is what's called an MMRTG, and he digs it out, and it is radioactive. It's got plutonium, And the plutonium has a half-life of 88 years. So if you had a whole bunch of it, and you counted up how many atoms of plutonium you have, in 88 years, you'd have half as many plutonium, and the rest would decay to other things. It would decay into neptunium and some other products. But it generates an alpha particle, which is 2 protons and 2 neutrons stuck together. It's also called a helium nucleus, okay? And it moves, decays, it moves, but it's not like it just takes off. It's not like it just flies through your body and kills every cell from the time it goes in to the time it goes out. So it's really kind of benign. In fact, you can stop it with a piece of paper. Okay? So when they decided to use the MMRTG as indeed something to heat the vehicle, I said, just wrap it. And that would cut down significantly on the radiation. It's exactly what they did. And that's very accurate. That's very accurate. Now, he's going to get radiated, okay, but it's nothing like the cosmic rays he's getting in any event. And this is really low level, okay? And typically, your body can handle aspects of this, although you don't want to do it for long periods of time. Now, one thing I didn't like is we would never take an MMRTG and bury it. And the reason why is it's generating heat. And right below the surface, we're finding that the water, the crust, is full of water. So when the ancient ocean was there, it moved into the crust in addition to being stripped off the planet, okay? Once it lost its magnetic field, the water cycle was broke. You have evaporation, transport, rain, and so what was happening, you'd have evaporation, and then the water molecule was busted apart, and then the solar wind would take the oxygen, never to return. And the hydrogen was light enough, it would take off too. So you're losing water like crazy on Mars. So what you have to worry about then is you could create a habitable environment, and there's microbes, human and other types of biological microbes on this MMRTG. So you actually can breed a colony, and planetary protection would not allow us to do that. So we'd never bury it, okay? We'd never bury it. So that's a little policy and law there, all right? Now, this is the real MMRTG. Percy's got one, Curiosity's got it, and he uses it in the book for many things, which is kind of cute, in addition to warming his vehicle. He also, once he's able to move around, takes off and goes down to Pathfinder and gets the lander, which is called Pathfinder, and the little rover called Sojourner, okay? And he brings them back. And indeed, you can read in the book how he did it. This is his path. This is his path. This is how he did it. Typically, NASA, when we land on Mars, we're gonna have an area anywhere from 100 kilometers. Right now, we're thinking more like 200 kilometers. We're going to call that an exploration zone. And so our astronauts are going to only stay in that area. We're not going to be driving all over Mars, okay? But that's okay. Another big drive that he does is to go from Ares 3 to Ares 4. This is his path. You can actually get it out of the book. And once I had it, I talked to Andy about it, and he said, yeah, that's the path. In fact, right up here, this is an ancient river valley that dumped into the ancient ocean of Mars. Okay, so it goes right up the river valley, and you see that in the images on the screen. And Andy verified that this is the path, and he was going to actually create a figure and put it in the book, but he thought that would give everything away, so why would I do that? So he just described it, and he did a great job describing it. Now, of course, with Percy, we landed. We landed in Jezero Crater. It's right here at a delta. Here's another river valley. This dumps into this crater. But this crater saddles the ancient shoreline of Mars. It's almost like a perfect placement of the crater. This river dumped into the ancient ocean. So then there was a crater, big, huge hole. And then the water, rapidly moving water that's coming from hundreds of kilometers up, go into Jezero Crater. And then the water is still. And so you have rapidly moving water hit with still water, and the silt drops out. So here's all the silt, okay? So when we take cores, we're going to be taking cores in areas where there's silt. Here on Earth, the ancient river valleys where we go to deltas where there's silt, we find past evidence of life all over the place. So we're really in a great place to make these measurements and bring them home. The crater filled up. It got so much water, it broke through the crater wall and then flowed into the Isidis Basin, which is part of the major ocean on Mars. So if I was to be asked, how close are we of knowing everything we need to know to really send humans to Mars, okay? On a scale of knowing nothing to a scale of knowing everything. And we're really doing pretty good. We're probably in the 80s somewhere. We're still finding all kinds of new and neat things and important things. But by the time humans are ready to go to Mars, we're ready to have them go. We're well on our way. And the helicopter is just one of the new dimensions. Andy told me that he wanted to get this book out before we landed Curiosity, okay, or before, which didn't happen, but before a lot of the scientific results from Curiosity came out, because he knew that would change the things that he would have put in the book. And there were a few of those things. But this is really remarkable, where we put this helicopter under the belly pan of Perseverance, dropped the pan, dropped the rotorcraft, and then drove away, and then literally took off. And we had 5 test flights. And what we're finding is this thing works really well. There was so many people, not only at JPL, but even within NASA, that says it'll never work. Okay, why are we spending money to do this? This thing is 4 pounds. So the body of it is like a CubeSat. All right, it's just a little nice little CubeSat. It's a little bigger than that, but it's got downward-looking camera, outward-looking camera. It's got an altimeter, and the blades are about 1 meter in size, and they are so thin you can just hold a blade with your finger. I mean, they're just really lightweight. And they spin, well over 2,500 RPM. And that's enough to lift this. We now know, based on how well this works, that we could probably supersize it and have something that's a helicopter that's 10 times the mass. And now we're talking really, 40 pounds worth of experiments. It could be a methane sniffer. It could be, all kinds of stuff that enable us to look for life and go places you couldn't take anything else. These are the first 5 test flights. Height 10 meters, total 271 meters distance. Time 140 seconds. After one flight, it only takes about 3 hours to charge back up, and off it can go, but typically we only do one thing at a time and then analyze the data and take a good look at it. But this thing got really sophisticated. Here's a flight, the 10th flight. You can actually see it took off. It just made that turn. Now it stayed at a way station. Now it's going to run around along the rocks, make another turn, and then come up and find a landing site. And then it makes that final turn, goes up, finds a landing site, and then comes down. And what you're looking is at the downward camera. We do these over the noon hour, okay? So you almost have direct sunlight, and you're looking right at your shadow, which is a really pretty neat way to do it. And the helicopter is so versatile, it's really starting to help the Perseverance team plan their plan their direct approaches to get to various places. Excuse me. But I can imagine these helicopters going into places like collapsed lava tubes, where we think the temperature and the pressure are about the same all day long. You remember I was telling you about the temperature variation? Imagine you can find a place on Mars where the temperature, is going to be the same day or night, all day long, all night long. We think that's what's happening in some of these lava tubes. We'd love to test that out. And of course, we then have the capability to do more imaging, temperature, pressure measurements, humidity, look for microbes and, even methane measurements. So relative to actually getting humans to Mars, we're really doing pretty good. We're going to be testing a number of things on the moon. The toughest things yet are landing. We can land 1 ton on Mars. But to have a station, a place like Ares 3, which we estimate is about a 40-ton system, we might be able to land 10 ton. So we may have to land several things and then robotically put it together before we actually go. And what we're planning is currently looking like this. It's called an exploration zone. So here is where Ares 3 would be, so you'd land in one location, you live in another location. There's all kinds of places you go to extract material, and use that for in situ resource utilization, or ISRU. And then there's a whole bunch of places you want to do science. And we've actually held a workshop to say, scientists and engineers, given the chance, where would you go? And here's the first shot at it. There's about 48 unique sites there. And we have tasked the Mars Reconnaissance Orbiter for every one of these sites to get some high-resolution imaging. And we now have that. And now the scientists and engineers are going to come back with the high-resolution imaging along with other sets of data and then argue which of these sites are better than others. And I'd like to see us at the end of the year whittle it down to maybe 20 sites or 15 sites. Okay? Now we're making progress towards actually going to Mars. So with that, let me end and thank you. I hope you enjoyed the movie. And I'm available for questions. So the mics will get to you, and then I'll answer whoever talks.
So who's first?
Thank you. So I was wondering, you were just saying that the site on Mars would be put robotically together before humans go there, right? In preparation. But Probably. We're, making guesses, but sure. So assuming that will happen, I guess there will still be a little bit of work left for when people will actually go there. First of all, do you expect that will be the case? And second thing, in case that's true, where would you expect the astronauts would stay? Would they stay in the lander, or would they stay maybe in some form of Mars tents? Or how would you imagine that?
Well, I think the basic idea is you'd have a habitat. So as you saw, the early habitats that we had at Johnson Space Center, they're modules that you would live in. And what Art Max did was link that concept together into a larger area. But that's what the first set of habitats would be like. The exploring of the lava tubes is an interesting idea, but it doesn't necessarily mean we'd live in them. We don't know enough about them, but they could be very appealing. But they're also not all over the place either. They're in the area where you see a lot of the volcanic activity, and some of these appear to be really pretty big because the gravity is so low. So what happens is lava moves over the surface. It literally carves its way into the soil, and then it actually then solidifies, and then the material, it solidifies from the outside going inward, and then the material continues to flow. What you end up with is a tube, an empty tube, Okay, and then if you had a crater that hit it, a meteorite that hit that and broke through it, then you have what we call skylight. You have access into a lava tube. So we need to explore those. That might be the best place to go. We don't know. So there's still a lot of things that we need to do.
Okay, thank you.
Is it me? Oh. Yeah. Thank you, Jim, for your great talk. Actually, we have lava tubes. We have lava tubes in the Azores, so if you want to check out a good analog place, just 2 hours flight from here.
Sure.
So one question I had to ask, and it's something that puzzles me. What progresses have been made in ECLSS systems, in other words, environmental control and life support systems, to bridge the gap of, for example, the 90 to 92% recycling ability of water and other things that you need humans to survive?
Right.
So,
right.
So that is the main question.
Yeah, I would love to be able to answer it. I'm not knowledgeable enough to answer that. John Connolly might be able to. And he's here. He's right over here. Can't hide from me. I saw you. But I know they're doing a lot of work on that. You know, that is a really big effort. Because they're going to have to do something like that on the moon.
Okay, so what did you... Uh-oh.
Yeah,
life support.
Yeah, the improvement in the eclipse systems, the internal suits and habitats.
Right. So Mars is unique in that life support systems don't have to be as closed as some other places because you actually have available oxygen.
Correct.
To you. So it actually probably doesn't make sense to spend all the money to fully close a life support system when you could just crack oxygen out of the CO2 atmosphere. What you need more than anything on Mars is a very reliable life support system because the repairman's a long ways away. And so I think the ones we're looking at are pretty, we're getting pretty good at life support. And I think we're looking at the same basic kinds that we use in space, and we're planning for the moon on Mars, with the addition of the fact that you can resupply gases to yourself and water. So water, if we find that on Mars, that's like worth gold because you get not only the water for human consumption and rocket fuel, but you get you could crack oxygen out of it if you want to. So I think Mars is actually easier on life support systems than going to the moon.
The water area that we really love is right here. This area right up here appears to be the ancient North Pole of Mars and has an enormous amount of water. In some places, it might be as much as 750 meters thick. And so landing sites, and we found this through ground penetrating radar. And so landing sites that are in and around here might be some of the best places to go because you can go in and mine the water, bring it in, and melt it.
So currently, the environmental control life support systems are able to recycle 90 to 92% of water. If you do the math, 30 cycles of consumption will last, for example, for a liter, you will consume a liter in 30 cycles. So that's 30 days for one human, provided he drinks 1 liter of water. So if you're doing a 6-month travel with 6 crewmates or 3 crewmates, that's quite a lot of water. So that was the reason I asked the question.
I'll drink to that.
All right. We'll consume some water-based beverages outside and discuss this some more.
Okay, thank you for the nice presentation. I really loved the Martian movie. My question is about growing.
I don't know if you noticed, but you should have learned a lot about Mars in the movie.
Yeah, I learned a lot.
I just
great.
Wanted to make sure you did that.
Thank you. My question is about growing up plants on Mars and astronauts' food on Mars. from the viewpoint of planetary protection, is it suitable to grow plants on Mars, or should we close everything not to go outside? I mean, from the hub, or what is your opinion about that?
Okay, I'm glad you asked me what my opinion was. Yeah, we're right now doing a variety of computer modeling, moving towards what commonly is called terraforming Mars. We're doing it in supercomputers, okay? And one of the things that we do is, the concept of how can we build up the atmosphere? What effect does that have on the temperature? Because temperature and pressure are related. And then how can we get the pressure high enough where we actually can go outside and grow plants? Now, what kind of plants should we grow? Well, they're going to have to be genetically engineered. And in fact, some research is being done right now for which they're going to plant trees. They have a chamber that pumped it down, put in CO2, and it's about the pressure of Mars, and they're trying to grow trees, okay? And trees are wonderful bringing in CO2, generating oxygen, okay? But how low a temperature can you get? And when would that be possible? Well, that may mean there's a stage on Mars for which we have to get it to a point, many of us call it the first level of terraforming, for which then you can start planting things outside. And then the next thing you want to go for is getting the pressure above the Armstrong limit. So right now, the average pressure is about 7 millibars. If you can get it up to 60 millibars, then your blood doesn't boil. Now, you're not constrained as much by spacesuits and keeping your body together as you are then just maintaining your body temperature. So that would be another level of terraforming. So all that's being done right now in supercomputers trying to figure it out. If we waited until we got the okay that there's absolutely no life on Mars, and so Mars could be inhabited by humans, and then start the process of figuring out how to live there, they're not going to do that. We're going to start thinking about it now. There's also, we don't know that there's life there. We know there's no life on the surface. That's firmly believed by our scientific community. There may be life below the surface. Maybe a fair amount of life. It requires what we think is water, and we're finding that there probably are some underground aquifers. There's indications of that. And so there may be, some microbial life that's living down there in some way. Why can't we share the planet? Okay? Maybe that life is really on its way out because this planet is wasting away. And the best thing that we could do is show up. There's all those aspects that need to be determined, discussed, and figured out. But we're not waiting for that. We're doing a lot of the modeling right now.
Thank you.
Yep.
Hey, Jim. So just to follow up with that question, I love the movie, so it's a great talk. I was wondering if you could do two things. First, comment on, so Mars is 1/3 gravity of Earth. So if you could comment on basically their motion, because it seemed like they were just moving very nicely.
Yeah.
And
so I asked Ridley that, why didn't he have some sort of, light spring thing? And he goes, they're wearing suits, they're heavy. That'll keep them down on the ground. Okay, you're the boss.
So I guess it'll be a bit more kind of relaxed walk in reality.
Well, they're not skipping. They're still walking. Okay, it's not like the moon, which is 1/6 or 17% of our gravity.
Perfect, thank you. And the last one is just regarding your slide for the Mars assets. I remember a couple of years ago I read that they did a test with 2 CubeSats. They sent them to Mars to see if it works. Yeah. But I never actually found anywhere the results. So I was wondering maybe if you could just...
Those CubeSats were things I funded. They were the Marco CubeSats, and they were designed to be relay spacecraft. So when InSight entered the atmosphere, it's sending tones, okay? And so we need an orbital asset to fly over and then listen to those tones, record them, and then send them back. The tones are really important because it tells us if it runs into trouble, where in the entry, descent, and landing process it occurred. All right, because we're gonna do a forensic analysis of that to make sure we don't have another problem like that again. And so, because of where InSight was going to go and how the orbiters were arrayed, we also decided to try this CubeSat idea. And the two Marco spacecraft were relays. Would hear those tones and send them back to the Earth, and they worked great. But they were designed to fly by Mars and never return. Okay, they did their job.
Hi there. Not a technical question, but what is your favorite scene or scenes from the movie?
Oh, actually, it's where he sits on the rock and he composes his thoughts that he sends to Commander Lewis. He says, Commander Lewis, I'm going to ask you to do something that's tough to do. I want you to talk to my parents. Okay, to me, that was a really emotional scene because part of that was ad-libbed. I have the script, okay, and it's coming from Matt Damon. He's really into the role, and I thought he did just fabulous. It was really powerful. It was really powerful. And he wasn't going to give up either. He was, this is just one of several possibilities. That's really, quite a outstanding individual to be able to marshal your mental strength too, to be able to do that.
Hi Jim, we have a question from online from Erin Robert Girl. She's asking, is there more to learn about the Mars atmosphere from the CO2 jets on the South Pole? Could it be a site for future robotic missions? Thank you.
There's always important things to learn. We believe, let's not make it so much the South Pole, but talk about the North Pole, because that's a much more permanent polar cap. We believe there's an enormous amount of water in the North Pole, but the spectrum is CO2. And that's because it has a collapsed atmosphere of CO2, a veneer, if you will, of CO2 over the frozen H2O water polar cap. And if you melted that, it's such a huge volume of water that 1/7 of the ancient ocean on Mars would return. So we want to go there. We want to look at it. We want to look at the stratigraphy. We want to look at what's happened in the history of Mars. That would be a great place to go. We do that ice cores all the time here on Earth, so it's really the same type of science. And I would dearly love to do that. It would be an extremely tough mission to do, but it would be I think well worth doing.
Once again, thank you. Regarding the dust devils, I have a couple of questions. The first is how often it happened that it cleaned the panels in the rovers that you mentioned, and what is the probability that it will clean inside? Because it's something that on Earth doesn't happen too often. That something that
InSight's in trouble. And we don't think it has long. The possibility that it would have a dust devil is low because of the season we're moving into is more into the winter area. So it's not expected to make it to Christmas. It'd be wonderful if it would, but we don't think it's going to make it. But it's gone through its prime mission and has had an extended mission. It's really done what we expected it to do and more.
But if it happens in a year time, it will come back to life, or?
No, once you freeze circuits, They're froze. I should have mentioned that it was unrealistic of Mark Watney to think he could get Pathfinder and Sojourner back up and running by just powering them up, because capacitors won't function. You'll have all sorts of circuit trouble. You won't be able to, do it.
Okay.
You don't freeze your phone lately, do you? Stick it in the freezer and let me know if it works in the morning.
Yeah. And also, the second question is regarding what is the mechanism that cleans the panels? Is just the wind, or is it an electric?
It's just the wind.
There is no electrostatic charge that can take the particles out, or
so yes, there is another effect. Okay, the really fine dust that falls hits other dust and moves it, and that moves dust, and that moves dust, and so dust creeps on Mars through this, in large part because of this dust interaction with dust. It's really bizarre, but that's what happens. So, thinking they might be able to use that idea, they actually took a scoop of material and dumped it on one of the panels on InSight to see if that process didn't help clean it, didn't work. I think they may have put too much dust on it, or they didn't put the right size dust. It's very size dependent when you to do that process. But it was an interesting idea.
Thank you.
Hi, Jim. I remember I saw this movie at the cinema. And I enjoyed it very much, and you just made me want to watch it again. I had two questions regarding the movie. First, I remember saying that saying the person that was me at the cinema, I know how they're going to rescue him. They were going to accelerate and go again to Mars without landing. But after thinking about it, I don't know how realistic that part is, because sending the Chinese rocket with the supplies, matching the speed, which is above the escape speed of Earth, to go back to Mars. And the second question is more related to the science part. If we already before Perseverance, there is water in the poles. Why don't we send missions to that area? There's more factible if there was life, it's there than in Jezero crater, or not.
The water's frozen. Yeah. So the pole, So we do want ice cores. That is an area we want to go to, but there's also buried ice, and the buried ice may be a better bet than going all the way to the pole. We had a mission that went to the pole, or close to it, at least what would be the Arctic Circle of Mars. It was called Phoenix, and it lasted only about 90 days, and it drove the science team crazy trying to get all the stuff done. Imagine your mission only lasting 90 days, and you're bound and determined to get everything out of it. How often do you sleep? Not very often. And then your efficiency goes down, and all kinds of problems occur. And at the end of that, I decided as head of planetary, I would resist any mission that's like 90 days. You're actually going to you're going to have an opportunity to really do the science. You're going to need more than 90 days, because it was driving this crew crazy. So, and I missed the first part of your question.
It was them, in order to rescue Mark Whitney, they accelerate instead of stopping.
They had ion engines. And they actually did a gravity assist around the Earth, and indeed that is viable. You do that. You can do that. So based on these opportunities, that calculation is correct. Andy Weir did a really good job when he did that too.
Thank you.
Mm-hmm. I will mention that there was a lot of back and forth over, the Hermes wheel. Nobody's asked me anything about the wheel. I love the Hermes. The first design of the Hermes I wasn't so crazy about. So, as we went back and forth and talked about it a little bit, they made the wheel bigger. It's still not big enough, but they decided it looked beautiful enough, we'll just use it that way. And I said, hey, great, it's movie magic. But I really loved the look and feel of the Hermes spacecraft.
Right.
Okay.
Thank you very much, Jim. I think now we will all go back and watch the movie again.
You're very welcome. You're very welcome. We did all sorts of tours. Okay. So there I am with Sebastian Stan, McKinsey, Davis, Nicole Stott, Chiwetel Ejiofor. We did interviews, and then I was asked to go to the premiere. I walked the red carpet. That's actually my favorite red carpet picture. I walked down one side of it where there were all cameras all over the place, and I got out of the limo. I was the first one there, and everyone goes, "Yay!" And I'm going, they don't have any idea who the heck I am. What are they talking about? And so I'm walking down. I didn't know what kind of pose what pose would I do, right? Ingenue, who knows? And so I got down to the end of the line, and I saw the NASA photographers, and I went like this. And about 30 cameras took off. I thought, why didn't I think of that sooner? Okay, because Watney does it twice in the movie. And then that night I gave him a NASA meatball pin. So whenever he did these interviews and whenever he talked, he's got his meatball pin on, then I know the night he did that. So that's always fun. And then here's the whole cast talking about the movie. And then here's the premiere of it at the Toronto Film Festival, and I'm way up there in the third row. You can hardly see me in the upper balcony, but I enjoyed it. Thank you very much.
Well, Jim, it's hard to believe that actually you have been with us almost a month now, and I think this is the first time actually you've probably stayed this long. How lucky you are, the class of SSP22, to have Jim Green with you for almost a month. Once again, Jim, thank you very much for being here.
The only thing I would say then is this is Scott Magri's shirt. I've actually